Hello there, and welcome to how to interpret my Plasmidsaurus sequencing results. This video will be a brief walkthrough on how to interpret my Premium PCR results directly on the Plasmidsaurus website. Once your results are ready, you're going to receive an email that looks a little bit like this one. You can see in the summary report, I've got a quick snapshot of the sequence maps of all of the samples within my experiment, so I can see how they fared. If you click this View Results button, it will take you to the order page. Now, on the order page, you can see we've got this summary table, which gives me a lot of overview information. And you can see that I have added a reference for these samples. So that can be done by clicking on Manage References and then uploading your reference there. You can either use the button or you can drag and drop your reference into the box. The accepted file types are FASTA, Snapgene, and GenBank. Now, the nice thing about that is we will automatically align your consensus sequence to that reference. And so you can see three different possibilities. You can see that if it matches very well, that we get this perfect match, that's denoted by this happy looking dinosaur. If you've got one or more mismatches, you get the dreaded chicken. And we've also got this egg denoting a likely match, and there'll be more on that in just a moment. Now, everything on the website is designed to be clickable, and you can see that I can hover over and get more information. And if I click, it will jump down to tube 1. Now we can see right away that we have got an insertion of one base pair. So in the reference, we're matching before and we're matching after, but my sample has got a G at this position, and this is very well supported by the underlying data. So that is good to know. We can also see that if I click on this button down here, it will take me to the next mismatch, which again we can see is an insertion of a single base. If I keep scrolling, you can see that in tube number 2, I've got a perfect match to reference, and that if I look at the per base information, I can see the amino acid prediction as well, and of course the read support at each position. So if I keep scrolling, tube number 3 contains that likely match. You could be forgiven for wondering what on earth a likely match is. Well, if I click on the insertion, you can see that we have got insertion of 2 G's, but if I highlight this, it makes it clearer that this is a homopolymer. And Oxford Nanopore has got a couple of types of systematic error. We've written a blog post about them, which we will link below so that you can read more. But because we know more than the base callers, we can say that this is a likely match. That is to say that any mismatches in this sample match the pattern of common sequencing artifacts. So here, because it is a homopolymer and this is a known issue, we highlight it as a likely match. That is to say, we think there's a chance that this really does match your sample, despite what the base callers think. And so we label that with an egg. That is to say, it could hatch into the mismatched chicken. We think that it probably would hatch into the happy dinosaur. Now, if I keep scrolling, you can see that in tube 3, I've got 2 different sequences. And that is a big advantage of Premium PCR. Because the sequencing adapter is ligated onto the ends of the molecule, you know that every read you get belongs to a different molecule that was in your sample, and so you're able to assemble these 2 consensuses are very distinct. And for the second consensus, again, it will assemble and be annotated, and you can jump around and click and copy the sequence if you like. In tube number 4, again, you can see that I've got 3 different consensus sequences, and they are completely different lengths again. So 300 bases, 8,000 bases, and 2,000 bases. The pipeline by default will assemble up to 3 consensus sequences that it finds. And you should be aware that because nanopore sequencing is a single molecule platform, that means that the number of reads you get is directly proportional to the amounts that were in the sample. Lastly, I'd like to show you the virtual gel. Now you can see this is designed to look like gel electrophoresis, where the brightness of the line reflects the read support at that length. So this is a great way to compare between samples, but it's also a really good way of looking within a sample. For example, you can see that tube number 1 has just got 1 molecular species in there, whereas 2 and 3 have got multiple, as we saw, and 4 has got a lot in there. And so this might reflect a lot of off-target PCR amplification that you would definitely want to know about, and you may be able to refine this into a few tighter bands with some careful primer design. Okay, well, thank you so much for watching, and I'll see you next time.